Hello, everyone. Welcome and thank you to the Real Life Building Striving to Minimize Life Cycle Impacts webinar. We're going to get started here in about 30 seconds. We'll give folks just a little bit more time to join. Okay, I'm going to go ahead and get things started. Hello, everyone. Welcome to the fourth webinar in our 5-webinar series on life cycle energy and other related impacts of buildings, brought to you by the U.S. Department of Energy's Building Technologies Office. Today's presentation will highlight real-life buildings that are striving to minimize life cycle impacts and the challenges and the benefits they've seen along the way. My name is Cedar Blazik, and I'll be your moderator for today's event. As a disclaimer, please note that this WebEx is being recorded and it might be posted on DOE's website or used internally. All attendees will be muted for the duration of the webinar. However, if you do speak during the call or use a video connection, you are presumed to consent to recording and use of your voice or image. To kick things off today, you'll hear a welcome and opening remarks from Mark LaFrance, a technology manager for Windows and residential building efficiency here at the U.S. Department of Energy's Building Technologies Office. After that, Leila Fidali, a AAAS Policy Fellow in the Building Technologies Office, will give a brief introduction to life cycle carbon assessment for buildings and building technologies. We will then hear from our 4 distinguished guest speakers. First up is Victoria Burrows. Victoria is a director of Advancing Net Zero, the pioneering World Green Building Council global project to ensure that all buildings are net zero carbon by 2050. Victoria supports the Green Building Councils participating in the project and other partnerships that provide funding and support, marketing communications, and the Net Zero Buildings Commitment. Victoria has worked for over a decade in the sustainable development industry. Next, we'll hear from Wes Sellens, a lead fellow who leads the materials and resources activities at the U.S. Green Building Council. Wes is responsible for the materials credits in the LEED rating system and guides leadership criteria related to construction waste, product manufacturing, material transparency, circular economy, and embodied carbon. He has worked in the public, private, and nonprofit sectors for 20 years on broad efficiency and sustainability topics. Up next is Victor Olgai, a principal architect directing Rocky Mountain Institute's building practice. Victor sits on GSA's Green Building Advisory Committee and recently was a co-chair of the committee's Embodied Energy Task Group. Victor has a wide range of experiences in architectural design and planning and has contributed to the design of hundreds of successful green building projects throughout the world. Finally, we'll hear from Travis English. As an engineering manager for Kaiser Permanente, Travis oversees a national team of consultants that provide design review for all of the firm's projects. Their reviews focused on established targets for energy use, water use, total cost of ownership, and USGBC LEED rating. English came to Kaiser Permanente with a long work history in various fields, including HVAC design, energy analysis, and project management. Welcome to all of our wonderful panelists. I'd like to ask you all to please use the Q&A function throughout the presentation to ask questions that we can ask our panelists near the end of the session. Next slide. After today, DOE will host one more webinar in this LCA series on December 17th. I encourage you all to sign up for our final webinar and to sign up for our BTO newsletter to stay up to date on our continued work in this space. You can find our office page at energy.gov. Next slide. And with that, I'd like to jump into our first poll question and learn a little bit more about all of you attending. First, we would really like to know, what industry are you all from? Please select one from this poll. All right, and Valerie, can we pull up the answers? Oh, great. So it looks like we have a large portion from federal, state, and local government, as well as a pretty healthy showing from our lab and academic research friends. But we also have almost a third of folks coming from consulting and corporate. And thanks to the NGO folks, nonprofits, and the students that are attending as well. Thanks, everyone. So once you've answered that question, we'd love for you to use the chat function to let us know what you perceive to be the greatest barrier in achieving a common vision for a decarbonized built environment. You can select one from the poll, or if you don't think your answer is represented here, please let us know in the chat. Okay, we've got some great answers coming in. Looks like over half of you have voted already. Valerie, if we can pull up the poll responses. So I'll note on here, so far it looks like very few of you have voted for lack of industry knowledge or lack of technical solutions. So that means most of you think that, we have knowledge out there amongst our peers, and we also have the technical solutions to get us there. What we're lacking is financial incentives, policy and regulation, and the lack of demand or understanding. So that one's really interesting and compared to the industry knowledge of maybe who needs to have that demand and understanding. So feel free to share more in the chat. But with that, I'm going to hand things off to Mark LaFrance. Mark, please take it away.
Okay, thanks, Teeter. So hi, everybody. So you guys are in advance of slides, right? Okay, I guess.
Yeah.
So anyway, so first I'll just say that I've been in the buildings office for over 25 years. So I'm the longest technical staff there. But I did do 2 years in Japan at the Asia Pacific Energy Research and 3 years at the International Energy Agency. So one of the things they wanted me to say was to talk a little bit about the international perspectives. And so, in the US, our rate of construction is relatively small compared to the rest of the world. So in developing countries like China and Southeast Asia, and of course Africa, there's going to be a lot more construction, a lot more embodied energy that goes into the construction of the buildings. We always care about the operating energy. So that's what we mostly focus at DOE, but we are starting to take more awareness of other things that includes the entire life cycle and of cradle to grave, which includes embodied energy. So I'm not seeing the slides. Okay, maybe let's see. Valerie, are you guys all seeing the slides, or just me?
Valerie, we're still seeing the poll.
Yeah, still seeing the poll. Okay,
Sorry.
so I don't need. Okay, so the thing is like the first slide just tells you that buildings consumption is the sector is the largest in the U.S. And we really have to address the existing buildings. But because the embodied energy in existing buildings are already there, but as we put new materials in, we always want to use materials with less energy component to them and looking at the environmental impacts. Okay, so here this is just the sector. So you can see buildings are by far the largest. Okay, we can go to the next slide. I don't want to take too much time. Okay, so in our office, basically, we do the entire cycle of policies from R&D to then integration and trying to help other people do deployment and what we would call a lot of times market transformation programs, supporting that, voluntary measures. And then we also have the regulatory authority for mandatory building efficiency standards, which is one of the most impactful things we can do. However, they are helped when they're supported by the voluntary measures. And then the building codes, we do a lot of analysis, but those are handled independently. We only have the authority on the government buildings. So in any case, this whole process is extremely impactful for what we can do for the country. Okay, next slide. Okay, so this is an example of Windows because I'm the Windows R&D manager. And you can just hit the next animation one. So, okay, so basically we went from single pane Windows to double pane low E, and significant improvement, 3 times more efficient. We also increased the embodied energy from 1 piece of glass to 2 pieces of glass. Glass is very energy intensive, but it's still about an 8-to-1 ratio between the energy it takes to make the window versus the operating consumption. So in the future, when we do R&D, actually we're going to go the other direction. So in R6 window, when we have a thin triple, we'll have only a thin piece of glass, and then a vacuum glazing that can get to R10 will only have 2 panes of glass. So we won't be increasing the embodied energy by much at all, but significantly increasing the performance. Now, if somebody goes from an R50 attic to an R60 attic, the additional benefits for energy efficiency are relatively small for the ratio of material. So we have to balance that as we look at the whole cycle. Okay, and then Layla is going to talk more about what some of the other activities we have. So anyway, so the appliance standards alone, have impacted a huge impact for every household. So I think recently President Obama just had he just did an interview where he mentioned one of the most impactful things that weren't noticed when he was in office was the appliance standards program. So we just got some publicity for that. Okay, Layla, take it away.
Thanks, Mark, for that introduction. So before I continue, I have to give a disclaimer. I am a AAAS Policy Fellow in the Building Technologies Office at the U.S. Department of Energy. However, I'm acting in my personal capacity today, and everything that I say represents my own view and does not represent the views of the Department of Energy, the U.S. government, or AAAS and ORISE, other organizations associated with my fellowship. With that out of the way, so as Mark was saying, our office has done great work. It's had a big impact. For instance, if you look at energy efficiency standards through 2016, those are expected to save 142 quadrillion BTUs, which is more energy than our entire country consumes in a year. Next slide. So this is really impactful, but there's something that we've been missing, and there's a lot that we have to learn from our international colleagues. Next. In particular, our office has focused on emissions associated with operating buildings, but there's a significant chunk of emissions that is coming from building construction. Next. It's really important that we address this because global building stock is expected to more than double by 2060. And if we want to be able to address the emissions associated with those new buildings coming up, we need to act now. Next. All right, so if we look at the whole picture, that's the life cycle carbon, which refers to the carbon emissions associated with all stages of a building's life. It includes both operational carbon, which is where our office has historically focused on the emissions associated with operating buildings. And it also includes embodied carbon, which refers to the emissions associated with all these other stages of a building's life, from extracting raw materials to construction through to the end of life and demolition or recycling and reuse. Next slide. So where are the biggest opportunities in this space, and where is our office needed? Where should we focus? And what can we do right now? One of my takeaways from our first webinar with Kate Timonen and Ed Masri and Michael Giroux was there's a lot to be done. There's R&D. We need good data so we can, value things appropriately in our decision making. And there's changes that can be made right now. And in that spirit, we have this webinar. So on that note, I'm going to hand it over to Victoria. Thank you.
Great, thanks so much, Layla. And hi, everyone. My name is Victoria Burrows. I'm the Director of Advancing Net Zero at the World Green Building Council. The World Green Building Council is a network of national green building councils all over the world, around 70 in total, including, of course, the US Green Building Council. And I'm pleased to share a little bit with you about our net zero whole life carbon vision. So this content on the next slide has already been covered a little bit with the emissions from the building and construction sector. You can move to the next slide, please. The building and construction sector is responsible for 39% of energy-related carbon emissions globally. And as we know, that's broken into around about 28% related to building operations. You can just click through. I apologize, I forgot there was no animation here. Related to both residential and commercial, but also 11% from materials and construction. And concrete, steel, and aluminium also contributes a huge amount of emissions, because of course they serve other sectors. But we have a huge responsibility as the building and construction sector to send some strong signals to those material industries to help ensure that they can produce lower carbon alternatives to those materials and make the necessary investment into the infrastructure and production processes to decarbonize those heavy industries. So on the next slide, you'll see a little snippet of what the work of green building councils around the world, including, of course, the US Green Building Council, who have introduced LEED Zero through the LEED certification program. I think you need, sorry, I can't see the slide at the side. I think I'm talking to the slide with all the green building councils. Some are producing certification schemes to help recognize buildings that perform at net zero, but they're all working towards this whole life carbon vision that we have established at the World Green Building Council. So by 2050, we want to see all new buildings, infrastructure and renovations to have net zero embodied carbon, and all buildings, including existing buildings, to be net zero operational carbon. So a huge challenge there to both address the performance of existing buildings and to ensure that we can build our buildings with net zero embodied carbon. From 2030, we think new buildings, infrastructure and renovations should have at least 40% less embodied carbon with significant upfront carbon reduction, and that all new buildings must be net zero operational carbon, again in recognition of how many new buildings we expect to be built between now and the mid-century. And our framework sets out some umbrella definitions for achieving net zero operational and embodied carbon that the Green Building Councils then determine what the most appropriate application is for that particular market. And in this case, in the US, it's manifested as LEED Zero. And so we set some guiding principles for how we believe these concepts need to be tackled in terms of best practice application. And for embodied carbon, it follows a similar hierarchy to how we address operational carbon. So preventing where possible first, and then maximizing the use of materials with low carbon footprints. And also planning for the future, thinking about how we can maximize refurbishment, demolition, rather than demolition, having deconstruction and dismantling of our buildings so that we can maximize the recyclability of materials and a circular economy. So finally, on the next slide, we produced a report last year called Bringing Embodied Carbon Up Front, which sets out all the various actions that need to be taken by different stakeholders across the entire value chain to ensure that we are working in the right direction towards that vision. And it sets out the sorts of actions that can be taken immediately, like establishing roadmaps by policymakers to kind of set the direction of travel for policy being implemented, what the sorts of actions that investors can make in terms of providing finance linked to lower carbon and alternative solutions, how designers can carry out all the various modeling and technologies, but that requires data from manufacturers on all the different products and their carbon footprints. So all of these different actions enable others to achieve their net zero goals. There's a shared burden here. We cannot achieve this vision relying on one part of the sector, one slice of the sector, and so we must all take actions in that same direction. And we're starting to see some really promising signals from around the world, from concrete manufacturers and steel manufacturers, from designers and developers setting some really high and ambitious targets, followed by investors requiring life cycle analysis on projects and policymakers in their planning legislation as well. So we're really optimistic for the future and making sure that we can achieve this vision and help address the embodied carbon of our sector. So I think we'll hand over to Wes next from the US Green Building Council. Hi, Wes.
Thank you. Great. That was really helpful. See if I can share my webcam. Yeah, thanks. I work in, as was in the intro, in the LEED department. So I'm just going to drill one level deeper in LEED. Next, please. And thanks, Victoria. That was a great overview. So our LEED rating system is now in many countries, and of course the US is our strongest presence, but it's growing in places like Asia and China and in Europe as well. And we're seeing a kind of global movement towards more and more sustainable buildings, which is great. And we continue to certify a lot of buildings per day. And I think the most important number, though, you see here is our LEED professionals. This is the number of accredited professionals, green associates, folks that have taken and shown their expertise in LEED. And that's really what makes up our US GBC, our Green Building Council. In terms of buildings, we have billions and billions of projects using these LEED rating system, and our most current version is LEED version 4. Next, please. And when we think about LEED, really, especially with LEED version 4, and now we're under the 4.1, our latest, our newest kind of update, if you will. But we try to take a systems approach to the rating system. So it's very common when talking about climate change to know that, you know, LEED is focusing on operational energy and things like transportation impacts and how people get to buildings. But a big piece of that is also embodied carbon, those materials that were mentioned earlier. So when we look to set the credits in the rating system for LEED v4, you can see climate change is the number one. That's 35% of our credits are earned in things that affect climate change or can reduce the contribution from buildings. And that includes all types, energy, operational energy to embodied and transportation. Really important there also is human health. We prioritize health as well. And of course, we know climate and human health are all combined along with all the other resources. So in LEED, we try to take these system goals into perspective when we write the rating system. Next, please. Now, going one level deeper into materials and the actual materials and resources category in LEED, a lot of similar themes you're hearing from Victoria and others about prioritizing low carbon materials. So things like start with the hierarchy, reduce, reuse, redesign buildings. It's all about making sure we have the lowest impact materials to begin with. And then if you do need to purchase new and new materials and resources, then things that like EPDs, environmental product declarations, make sure your products have those. Do whole building life cycle analysis to lightweight and minimize, dematerialize your projects. And then look at optimized products where possible. And we're starting to see more and more low carbon materials that are on the market. And also a shift, kind of looking at circular economy, a shift to bio-based and sustainably harvested materials, because that does tend to have a lower carbon footprint. Now, you'll also see on this slide is health and circular, and those are the other priority areas for materials. And so, if we have a product or a material that's low carbon, but say it's very toxic to produce, or it's a one-time use thing and doesn't have additional lifespans, we have to really think about how we prioritize those. So it is all of these three attributes kind of working together to create those green products. Next, please. Now, when looking at how to address specifically embodied carbon and LEED on projects, and we're seeing this in billions of square feet of projects now that are doing LEED v4 and 4.1, they're selecting credits in the rating system that do address embodied carbon. And we kind of look at it at three different nodes of interaction or intervention. There's the design team, the things the design team can do to design and reuse and look at ways to reduce the overall carbon footprint of that project. And once the design phase kind of moves on to the next, they can look to product manufacturers. If you're in the manufacturing space or the R&D space for companies and manufacturers, there's a lot they can do to reduce the carbon footprint of that supply chain. And we know that's where a lot of these kind of hidden emissions are in that supply chain. So things like EPDs, and again, shifting to renewable products and materials, circular, recycled, that's where you find a lot of traditional green strategies as well. And then finally, at the construction side, there's a lot of opportunity for the construction teams and the specifiers that are procuring materials to do things like recycle waste first and foremost and design out waste, but then also procure low carbon materials. There's things like the EC3 tool, embodied carbon calculator, that's out there to help with selecting materials and products that have lower carbon footprints and result in also, you see the reduction of total waste. So there's a lot that all project team members can do, so everyone has a part to play in reducing that carbon footprint. And I'd say a lot of these credits that you're seeing, these are all kind of credit strategies in LEED, are being picked up. Things like the EPD credit are now probably one of the most utilized material credits in the rating system, and approaching levels of like construction waste. So we're starting to see trends where the manufacturers are producing low carbon products and design teams are really asking for that data and achieving it in projects. And I think that's my last slide. Next one is just some wrap up and thank yous and more information. So I'll stop there. Thanks. I think I turn it over to Victor now.
Greetings. Thanks, Wes. My name is Victor Oljai, and I'm a principal with Rocky Mountain Institute. I'm here to talk to you today about some work that I've done with the GSA Green Building Advisory Committee. The Green Building Advisory Committee, or GBAC, provides independent policy advice and recommendations to the GSA's Office of Federal High Performance Buildings. And this is originally set up through ESA, the Energy Independence and Security Act of 2007. And the purpose of ESA is to advance federal building innovations in planning, design, and operations to reduce costs, help with the agency missions, enhance human health, and minimize environmental impacts. So what we did was we set up a little task group within the GBAC, and we wanted to see if it would be worthwhile to think about low embodied energy and carbon materials. And if it would be worthwhile, then we should produce recommendations. And so I'll be talking to you today about these draft policy recommendations. And to be clear, these are draft recommendations which have not been adopted yet, but they are scheduled to be presented to the Green Building Advisory Committee in January of next year. Next slide, please. So this is the mission statement of the task group. Basically says that we're going to be looking at the energy, carbon, and pollution cost savings that are achievable through looking at low embodied carbon and energy materials. And if it would be significant, that we would produce readily adoptable procurement recommendations for the GSA to consider the adoption of these low embodied energy and carbon materials. So that's the task that we had. Next slide. So first we set up this task group, and the task group had representation from various government agencies, some industry groups, a lot of subject matter experts. We probably had about 30 people typically on these calls. And we met by teleconference bi-weekly starting in February of this year, excuse me, and for about 6 months. And when we started out, we had a series of webinars to kind of get everybody up to speed and sort of level set and understand kind of what the scope of the problem was. Then the next thing that we had to do was to try and figure out what was the value of this work to the GSA. So we looked at how much the GSA builds, and as you can imagine, it's quite a lot. We looked at 10 years of construction data, and on average, the GSA spent about $1 billion on 44 projects, totaling over 23 million gross square feet per year. So a lot of opportunity there. We then took a look at using Carbon Leadership Forum's baseline numbers, which you can see on the right-hand side of the slide, and tried to work back from what the 80th percentile would be, about 555 kilograms of CO2e per meter squared, to an achievable target, which we thought of as the 259 number. And this gave us a savings of about 633 million kilograms of CO2e potentially on an annual basis. So this is roughly equal to about the savings of 77,000 homes' annual energy uses. So it's really a lot of energy that could be saved. So because of this, we decided to go ahead and produce these low embodied carbon procurement guidelines. Next slide, please. So we had these discussions and we ended up coming up with sort of 2 key policy recommendations. Because the GSA has both leased buildings as well as owned buildings, we produced one set of guidelines for smaller projects, which are often tenant improvement projects, and then another set of guidelines for larger whole building new construction projects. And we worked to align these guidelines with existing federal protocols, including the prospectus procurement level, so how they actually procure these services. And this year it's about $3 million, a little bit more than that. So projects that were less than the $3 million would take this materials approach, and prospectus level projects would actually go for the whole building life cycle approach. And these are the larger projects. So the material approach is centered around providing basically EPDs, environmental product declarations, for the top 75% of materials in the project. And this can be by weight or by cost. And the EPDs provided have to be in the top 80th percentile of the best producing products. So this means basically we're getting rid of the worst products. The larger prospectus level projects need to meet this materials approach, and also they need to do a whole building life cycle assessment. So when a project team does a whole building life cycle assessment, they can actually make a lot better decisions than when they're just doing it material by material. And for the whole building life cycle assessment approach, we basically refer to other green building rating systems such as LEED 4.1. And we ask that they achieve a 20% reduction compared to a baseline building. And this hopefully for these larger projects will give us a lot of opportunity to have better projects on a life cycle basis. And also by having a material approach, it doesn't kind of impose undue hardship on these smaller projects, tenant improvements and so forth, where they may not have the budget to do really deep analysis. Next slide, please. So these, as I mentioned, these recommendations have been yet to be submitted as recommendations to the GSA. That'll probably happen this January. But there's a whole lot of benefits that we see that this can have. Of course, reduced embodied carbon costs can be correlated with energy costs, and we see this in the range of $10 to $15 million a year, let's say 13 millions. And that is not directly benefiting the GSA, but since it's in the supply chain, it benefits taxpayers as a whole. Air pollution is probably the most common quantified element and can be considered to be approximately $12 million a year in terms of savings. And of course, there's a lot of health costs associated with that as well. There can also be reduced costs from more material efficient designs. And this is something which has not been well quantified, but we suspect that it actually is can be very significant. The ease of regulatory compliance is really interesting because I think as more and more of these regulations come into being around carbon and embodied carbon in buildings, the GSA will be in a much better position to meet these emerging requirements. And then finally, there's the kind of climate change related cost. And this is really kind of the biggest thing. Sometimes we think of these as externalities, but obviously many of us have been experiencing 2020 with the extreme number of wildfires and other climate related disasters, hurricanes, so forth, and reducing the amount of carbon that we use to build our buildings. We'll be actively working towards mitigating this climate change. So that's what we've been doing. And thank you for your attention, and I'll turn it over to Travis.
All right. Thanks. Yeah, my name is Travis Inglis. I work for Kaiser. And in this context, we are a building owner and a developer. I'm the director of engineering for our design and construction program. I watched the other sessions in this seminar series, and I'm a little out of place. You're going to see that, but I may actually be the only panelist yet that represents someone who's spending capital on buildings and paying energy bills and actively managing an energy and carbon portfolio. So I have a scary story that I'd like to tell you in the next 5 minutes that I think it's a good time to listen to and maybe heed it. Okay, next slide, please. So some quick history. Our organization, we started requiring models for all of our new construction projects in 2012. Those are energy models, not carbon. We standardized our life cycle cost assumptions and modeling assumptions and all of that. Next slide. These slides will go fast, by the way. Then in 2017, we had built a bunch of buildings, 19 buildings to be exact, and we opened them and we ran them for at least a year, and then we came back and we looked at the design model versus the building performance. And the error between the model and the bills was between minus 19% and plus 160%. The average error was 50%. Next slide. And so there's a whole bunch of reasons why those models vary from reality, but the point is that they do. And at this point, there's even a name for this. You know it's real when it has a Wikipedia page, right? So this is called the Building Energy Performance Gap. And it's pretty big. My study was 50%. I have a friend in the Netherlands did a study and he found 60%. You see some real optimistic stuff produced by consultants that talk about 10 or 15%, but realistically for new construction, right now we're sitting at about 30%. Next slide. So we came back to our standards about 2016 and we did two things. First off, we told our project teams, thou shalt assume at least a 10% margin of error on existing buildings and 15% margin of error on new construction. That was unpopular. The second thing that we did was we added to our contracts that our design professionals must predict energy consumption. And this is important. They didn't want to do that. Our design professionals wanted contract language that these models are theoretical, they're for comparative purposes only. So we've had to try to put a hard stop to that and say, no, your model must be a prediction of the facility performance. And yes, we are going to check it. Go ahead and go forward. So this is one of those calibrations. I don't want to spend a bunch of time on this. I'll point out this one was 63% difference, and there are natural gas is a 200% variance. That has turned out to be a running theme. It turns out our industry tools are very bad at predicting natural gas. Next slide, this next slide is just to say that we're continuing to do these reports here in 2020. My hope and my goal has been that over 5 years we could shrink the gap, but I got to tell you that is not going well. We've had some projects that come in really close to their model, but most of the errors we see, even a few years into trying really hard, are still pretty big errors. So go ahead and hit the next slide. This is the last slide, but I'm going to continue to talk here for a minute. So first off, the story on this slide, which is a story I've learned to tell. I was in my office. A project team came in. They had this young, brilliant PhD modeling guru with this folder full of life cycle models, and he presented all of his models for 40 minutes, right? It was very clear that he had worked on them for 6 months. And at the end of the meeting, I, the big bad mean owner, took my calculator, and the difference between the biggest energy number he showed and the smallest energy number he showed was 9%. And so I told the whole team, thank you for all this work. None of these options beat the credibility of the model, and so we, the owner, want the lowest first cost option in all cases. In other words, I'm not going to invest in any of your ideas because your modeling isn't credible enough to earn the investment. You can actually kill the slides at this point, but I'm going to continue to talk for another minute. You'll notice that I didn't talk about embodied carbon or yet, right? Just so you know, by the way, Kaiser Permanente is carbon neutral. We do manage our carbon portfolio, scope 1, scope 2, carbon neutrality. We announced that this year. We don't do embodied carbon yet. That word is yet. I can't really say anything about that. The title of this seminar, though, is Real World. And so I want to tell you this sort of Nostradamus story, because I think in the rearview mirror, we made a big mistake with building energy efficiency. It was unintentional, to be sure, but we created a zero accountability industry. ASHRAE 90.1, California Title 24, LEED for that matter. For the last 20 years, we've had architects and engineers going out there doing these models day in and day out. Owners pay for them. Government agencies are stamping them with smiley faces. And we have kind of created this industry culture where the people producing the models don't care. They don't have an incentive to care. They don't have a legal and professional liability to care whether or not and to what extent those models come true. And so I really want to put that in your mind because I know there's a lot of policy people on this call. I'm not a policy guy. I'm just a project guy. But I would urge you to think about that. Accountability and credibility and the ability to attract investment actually probably won't hurt you in the first 5 years of a policy. You know, we heard Victor and RMI talk about there's probably 20% and 30% differences that you can make in projects right now, no cost, low cost, you know, it's not going to hurt you at that point. But what I would want to put into the seed I want to put into your brain is to think out a few years, think out to 2030 or 2035, which is not that far away. We don't want to have project design teams, architects and builders doing non-investment grade embodied carbon models right next to the non-investment grade energy models. You don't want the owner to tell you that I can't invest in your options because the modeling isn't credible enough to earn the investment. I think on a 10-year timeline that could actually hurt or even kill the ability to attract investment. At some point, you're going to need to attract investment for these things. So that's my little story and something to think about, I guess. Thanks.
All right, thanks so much, Travis. At this point, I'd like to invite all of our presenters to turn their videos back on for the Q&A. To kick off our Q&A session, I have a question for the entire audience. So there are a variety of tools and resources that exist now to assist organizations in making life cycle impact decisions. What additional resources would be most helpful to you? I do invite you to give suggestions directly in the chat or into the Q&A box, and we'll be looking at those answers. Okay, so the first question for our panelists comes early on in the presentation, are panelists seeing any trend in changes in investor or market desire for net zero? So specifically looking at investments in the market. I think I'm going to ask this to all of you. We'll start with Victoria, then Wes, Victor, and then Travis.
Yeah, and thank you for the question. I mean, I think, you know, what we're really seeing in terms of trends is that there needs to be this kind of push-pull of industry, right, of all of the stakeholders across the value chain. We need to be able to create the confidence from industry that we know how to design net zero buildings, right, and that we know that the solutions that are out there, unfortunately, there's not sort of one single combination of measures, as Travis will know, to help us to get in every building type to the net zero, the magical net zero balance. And so, you know, we really need to be creating that confidence to policymakers and investors that we are ready and we have the answers to some of these solutions, which then enables this kind of ambition loop of policymakers to say, okay, this is where we're headed, this is what we're going to start asking you for. And the same with investors. Investors can start demanding that their investments are being shown to be made into projects and initiatives that are not effectively going to be stranded over several years because they simply don't meet the criteria. And so through sort of a little bit indirectly, I would say at the moment, it's starting to come into the market where investors are specifically saying, I want to see net zero, but they're certainly starting to ask for more transparency and disclosure around how organizations are prepared. And so that does mean their assets as well. And also starting to look at performance data as well. So not just, you know, how green or how much better is something than regulation or code, but how is it actually performing in operation? And that's what they're most interested in. And so we're definitely seeing the trend in the right direction. It's just around the corner that they'll start asking specifically for net zero, for low embodied carbon, for the whole life cycle approach as well.
Yeah, and Wes, you're picking up on that. I think we are seeing some interest and some strengths in understanding how to design for zero energy buildings, like operations, at least on paper, Travis, to your point. The embodied carbon piece, there's still a lot of question marks. What does zero mean? What's the role of offsets? What is the scope? Like, how do you draw that boundary? Is it the people coming into the building, or is it just simply the scope 1 and 2 emissions in the building? So things like that are still question marks. We are seeing increased interest, a lot of talk about it. I think in LEED, to your point, Victoria, we're pushing towards the O&M rating system, operations and maintenance, the ongoing performance. That's where we're, you know, those project teams and those owners are able to show that they're actually meeting those goals. And yeah, I think that's, I think it's a trend. It's still a challenge. Like, we've had LEED for Zero out for a while now and don't have a lot of projects that have taken it up. It's still kind of an aspirational goal. When you look at the total carbon package, not just energy, but you look at the additional things like water and transportation and embodied, there's still a lot of question marks. But certainly lots of interest and lots of energy around it. I think I'll stop there.
So it's always hard to figure out what to say that hasn't been said, but I'll jump in and say that I think we have a lot of interest, and especially in the operational side. I haven't had quite the same problems that you've had, Travis, in that a lot of times, you know, as the building is operating over a period of time, we can true it up. And I think, you know, now, whatever, in the last 5 years, we've seen a lot more, you know, net zero buildings being built that are actually net zero. You can measure it, you can see it happening. And so I think that the variation that we've had in predicting operational energy in the past is starting to get better. So I think people in general demand that, and we see that happening quite a bit. I think the other thing that's starting to happen is the embodied energy piece is really interesting, because I think it is sort of emerging in terms of people understanding what the costs associated with it are, and to what degree they can actually just make a better building easily, you know. And I think this happened with operational energy too. We sort of figured out, hey, maybe it's not more expensive to do some of this stuff. We can just have a better building pretty simply. So I think that's starting to happen with the embodied energy, but the embodied energy is even more kind of difficult to discern, because you know, when a concrete is poured on your site, you really don't know what's in it necessarily, right? So it's a bit opaque there, so to speak. The last thing I would say is that there's, I think, an interesting kind of growth in demand, not only for buildings themselves to be lower or net zero operational and carbon, but also to interact with the grid better. And so we've got a sense now that buildings themselves are part of a larger system, and you can actually start to have buildings be interactive in a way that benefits the owner of the building as well as the utility and the larger community. And what this also implies is an electrification of buildings. So we're starting to get rid of combustion on site and starting to make buildings more interactive at a neighborhood or a campus scale.
Yeah, that's a good. I like what you said, Victor. I'm a Rocky Mountain Institute fan, by the way. So
Yay.
it's trying. We're trying to figure out what to say that hasn't been said. I know for us, I'll just tell you, we have our first. I'll brag. We have our first net zero energy building that actually has the bills to prove it. So 1 year's worth of production, 1 year's worth of consumption, net zero. It was our 5th or maybe 6th net zero design that actually produced a net zero building, which I think is that goes back to the investment thing, right? So how much extra are we willing to pay for net zero? And the answer is literally zeros. The whole position that myself and the design standards team have been in is that we're an owner. If we're going to put a building into service, we have $1 per square foot budget that puts that building into service. I push our architects and engineers to include the energy goals and include the LEED goals and include all that stuff in there, but you don't get an extra dime. You got to do that at cost. And we've actually been very successful with that. That's not really, you could push that to a certain degree, right? You can take, it's very difficult to go to, gap level innovations when you have to do it at solid first cost. But if you want to go to gap level innovations that are investment ready, then they got to be investment ready in order for me to go to my board and say, listen, buy this and I will show you in 5 years that this is going to happen to your bottom line. So.
And I would just perhaps add to what Travis was just saying, Cedar, because the leadership of organizations like yours to kind of put your head above the parapet, as it were, and kind of take the actions to, as I said earlier, to sort of try and stimulate the supply chain and the innovations and the technologies to bring these on mainstream is only going to help make the business case stronger in the future. I mean, I think Wes mentioned earlier that net zero is aspirational in most markets. It's intended to kind of be right out there as kind of the target to be hitting. And what we sort of try and encourage people is to think about where maybe the business case isn't quite stacking up because of those technologies and you're not able to deliver it at net zero cost, that you're making preparations and making sure that the building is net zero ready, at least for the future, in anticipation of decarbonization grids. Think about electrification, think about energy efficiency, think about future proofing, so that in the future, when we know this legislation is coming, then you can kind of layer up those technologies in a more cost-effective way, and that might be a more appropriate solution to some markets.
Thanks for that addition, Victoria, and thanks for all your answers, everyone. So the next question is kind of a big one, but I think it's really important. Given the long lead time and lifetime of assets, what do we need to do right now? And you can interpret that as we as an industry, as the buildings industry, but I'd also love to hear if you have any perspective on what you think the Department of Energy or the Building Technologies Office could be doing as well. If you don't mind, I'd love to go in reverse order this time. So we'll hear from Travis, Victor, Wes, and Victoria. What do we need to do right now?
I really think that I think that we really need to have a whole lot better understanding of this is just off the cuff. One of the things that I find to be really problematic is that we are extremely good at estimating the first cost of buildings, right? We can estimate the first cost of buildings plus or minus 1%. If there's a 1% variance in that, then the project funders can come back and raise havoc, and we'll get it back to a 1% variance in the initial cost. Energy, I've shown you, is very different, right? That's more like a 30% margin of error. Repair and maintenance and replacement costs and end of life cost is almost a complete black hole. I have never written a successful business case that has to do with equipment life or failure rates or annual repair and maintenance costs. It really is just a total black box. And I think that's part of the overall, that's part of this overall life of buildings, and that goes for envelope systems. And I think that really is just there's a black hole that we need to start filling in some information from.
Great. Yeah, I agree that there's definitely a lack of information and a lack of kind of real world sort of case studies that people, one of the great things about buildings and working in this field is that they are tangible, and so people, if you can actually get success stories out there, then people can follow them. And I think that is really helpful. I think that, energy efficiency in buildings and embodied carbon in buildings, it's just not on the top of most people's radar, unfortunately. I know I think about it all the time, but not everybody does. So I think what we need to do is increase the demand for these products and to show people what the opportunity is for that. And so that's why I'm so excited about kind of the GSA policy stuff, because they have a large amount of market pull. So I think that, clearly I love the idea of having, it be zero additional cost. That makes sense. A lot of times we don't, need to justify this in terms of, payback. We should just say, this is a good product. We're buying something that's good. But we need to increase the demand for that. And I think in order to do that and to get it on people's radar, we need to either have additional codes, we need to have policies, we need to have preferential procurement, we need to have a heightened awareness amongst the people that are actually purchasing these products. And I'll turn it over to Wes.
Thanks, Victor. Those are great. I'll take a little different angle, just from where my head is in the materials category and lead. When we're looking at embodied carbon, one of the biggest, most impactful things a project team can do is whole building LCA. When you have a large project that's doing a whole new structure or able to reuse or something, to do that whole building LCA. But to Travis's point about energy models, I mean, they're as good as the data you put into them and the baseline assumptions you make. I think that's one of the challenges of energy models, right? It's how good is your baseline, your base case. And I think with whole building LCA, honestly, what we're seeing is a lot of just widget substitutions, like a low carbon cement or a recycled content this compared to a non-recycled content that. And those aren't getting us the scale of change that we really need. I mean, these problems are huge. Like the climate change issue is massive. I'm in California. We were basically shut indoors all summer, most of the summer due to wildfire smoke. And not to mention 100+ degree temperatures outside. I mean, it's coming every year. It's getting faster and faster and heating up literally. So the problems are huge. Not to mention things like land use and social equity impacts and supply chains. So really getting whole building LCA right. This is something we are just dabbling with in LEED. How do we stitch together the operational energy model, for example, and the LCA model and make those something that truly optimizes like for a total carbon solution, not to mention things like transportation. And so we're dabbling in that. There's tools out there, but something that the DOE could do is really help create good baseline models, good assumptions for LCA, for EPDs, et cetera. I mean, there is good data there and it's getting better, but what we need are those appropriate baselines, and groups like the Carbon Leadership Forum and others are helping to create those. But really could use more that on project expertise and showcasing these things. I mean, in LEED, I'll shut up in a second here, but we have a credit for LCA, and the first point is just do one, because we know we just need to incentivize that market to do it. The other points are for starting to reduce by 5, 10, 15%. The fourth point you can get in LCA right now is if you reduce and you reuse some portion of a building, either offsite or onsite, do building reuse, because we know that is a tangible benefit that can't be fudged in the numbers. It's real, it's marketed, you know. Anyway, so something around LCA and getting those whole building ACO models as tight and good as we can, and establishing good baselines would be great. That's on my wish list of things to do.
Okay, so Wes almost stole my point, but I think I can still pull it back. I'm really interested in the survey results from earlier that was asking about the barriers to common vision, and that's, I think, the 4th time that I've been involved in a session where that exact poll has been run, and the same results has come out every single time. And the one that surprises me the most, like policy sure, financial incentive sure, the fact that we can deliver these already, yes, we know that. What really surprises me every time is this lack of demand and knowledge, because as we say, we're living this, right? We live and breathe it, and we hear about them all the time, and yet in the big wide world there is still this enormous lack of demand and knowledge. And so I think, to Wes's point, it's about asking the questions, it's about doing those calculations, it's taking it as far as you can and asking those questions on the project and challenging yourselves on these projects, or as clients, or wherever you sit among that value, across that value chain, and ask yourself why you're choosing to do it in a certain way. If you're not choosing the building to be all electric, why not? If you're not selecting low recycled materials, why not? And make a justification. And if you can't kind of make that marry up in your head, then take a different route. Can you use an existing building instead of building new? There's all these different questions, and there's so much power in just shooting for the stars and setting those targets and asking those questions.
I think those are all really great points. Thanks, everyone. So I think we have just time for one more question, and I think this one's really key. So some programs promote just operating efficiency while others focus on embodied carbon. Do you think we need a combined metric so that both are considered together and integrated? Do you find value in keeping them separate? And are there any tools that are out there right now that holistically combine both? I'm curious to hear from the lead folks first. So maybe Wes and Victoria, and then we'll hear from Rocky Mountain Institute, and finally what Kaiser's using.
Yeah, I think I touched on that a bit on the last one. There are no perfect tools yet. I mean, I think that's where we're at, is we're still kind of competing. I wouldn't say competing, but we have different scales. I would say on the energy model side, there's a tendency to think, Travis, close your ears, but there's a tendency to think those are more sophisticated and better developed than the whole building LCA models. And so when you get experts in a room, they disagree about the accuracy of the models from LCA or from energy. And so putting those together has been a struggle in some ways. We're testing some ideas. We're starting to look at also interior LCA. The interior scope of projects are also a big thing, not just structure and enclosure. So looking at finished materials and finishes and things like that. But no, there are no great tools that I know of that stitch those together. There are a lot that have assumptions, but those assumptions can be wildly accurate or inaccurate depending on all types of data quality, right?
Yeah, I think I would agree with you there, Wes. And again, it comes down to asking those questions and understanding what the different options are that are available to you. The tools are getting more sophisticated, but they very much rely on the robustness and accuracy of the data that's going into the tools in order to make sure they're actually creating meaningful decisions and informing those decisions as a result. But the answer really to the first question is yes, you should be considering both together. You should be understanding what the impact of a material choice will have on the operational performance of a building, and vice versa. You should always be taking that whole life cycle approach. And sort of data that's not quite fully accurate is better than sort of just kind of flying without any information whatsoever. So just ask the questions and use what you can that's available with the tools. They're not perfect, but they're being refined over time as we get more information about the solutions we need.
Yeah, it's really a great idea, and we do use different metrics right now for operating and embodied carbon, but it's carbon, right? And it's I think that we can kind of start to think about a carbon budget for buildings. At RMI, we did produce a tool called Green Footstep about 10 years ago, which started to look at how you can balance operating and embodied carbon and think about a budget. And the budget has to actually include what happens to that carbon outside of your building. Essentially, we're getting all of our ecosystem services from the landscape. That's why we have these targets of 1.5 degrees centigrade and 2 degrees centigrade, because it has to do with how much the Earth can actually absorb. And so we do need, I think the larger tool is understanding goals that we're aiming for and trying to have your overall building come within that carbon budget. And the whole building LCA tools we have and others help us get there, but it's all about carbon.
Yeah, I guess as the owner who's kind of paying architects and engineers for their services, I'm a little bit agnostic as to whether or not, well, I try to stay agnostic as to which tools get used, and then whether or not there's a God tool or, multiple tools that are cobbling together into a report. I don't know that I would necessarily have an opinion on that. It's funny, just to push back on Wes a little bit, I think that maybe as a mechanical engineer and a former energy modeler, I've been most impressed by the product declaration lists for chemicals of concern, right? I look at those and I go, wow, that's great. And then my friend Joel, who's in that side of the equation, he says, oh man, let me tell you about those tools. Your energy models look really, really good. And so there's a little bit about if you see the sausage being made. What I've tried to sort of push back to what I was presenting, I think there's got to be some aspect of essentially professional accountability. An architect or a design professional, quite literally right now, when they publish an energy model, there is no professional liability or professional accountability that the outcomes of that model have anything to do with reality. And since we've sort of established this paradigm where that doesn't exist, to go back now to the chief counsel of all the architect firms and say, hey, listen, when you publish a whole building life cycle cost, we expect it to be plus or minus whatever, or we expect you to publish it with some sensitivities. That's going to be very difficult. But I don't think that conversation is avoidable. I think to Victoria's, organization, right? The idea that we're at the point in energy now where when you say you designed a net zero building, I want to see that come true. And so that's going to lean back on this idea of professional responsibility and professional accountability. And frankly, the contracts of the architects and the license agreements and their state licensure and all that, right?
Thanks so much for that perspective, Travis. So with that, we're at the end of our time. I'd like to extend my deepest gratitude to all of our panelists today, not only for their presentations on this webinar, but for all the great work that they're doing out in the world on this topic. I'd also like to thank our audience for participating in these conversations with us and our office. And we hope that you'll join us for our final webinar, looking at the intersection of life cycle impacts and circular economy potential for the building sector. Thanks again, everyone.
Thank you.